Here we go with lesson 3. So we're moving on to proving triangles similar. Now you see that word proving and you probably get a nightmare from last unit. We're not doing proofs like you're used to, okay? It's a lot easier here, but it is important. So right away, I'm gonna jump in and tell you that there are 3 ways to prove that triangles are similar. Now, make sure first thing you understand that this is only triangles. These 3 ways do not prove that quadrilaterals are similar. It only proves triangles similar. First one is angle-angle similarity, and you will see it written angle, angle, and you need that little symbol there because that's the similarity part. Okay, what that says is if 2 angles of one triangle are similar to, or sorry, not similar, congruent to 2 angles of another triangle, then the triangles are similar. Not congruent, they are similar. Right? This didn't work with congruence. Angle was not a thing. Okay, but in similarity, it is. All right, so here we go. There's an example there. How do we know the triangles are similar? Well, right away you can see that 2 angles are similar, or 2 angles are congruent. So this is angle, angle, similarity. What is the similarity statement? Well, I'll say triangle TRS is similar to triangle what matches up with T, P, what matches up with R, L, and then M. Okay, that one's pretty straightforward, at least in that example. Method number 2 is side angle side similarity, which you probably guessed it. This is why the symbol is important, because if you do that, side angle side is referring to congruence. This is referring to similarity. If 2 sides of one triangle are proportional, long word, to 2 sides of another triangle, and the included angles are congruent, I'm just going to use the symbol, then the triangles are similar. Notice again, angles are congruent, sides are proportional. All right. Now I'm telling you right now the 2 triangles are not similar. Why are they not? It looks like side angle side here. It looks just like side angle side. You got 2 sides and the included angle. Well, the 2 angles, O and H, are congruent. They're both right angles. Let's look at the sides. 3/6 and 4/10. 3/6 reduces to 1/2. 4/10 reduces to 2/5. Those are not equal. Therefore, they're not proportional. So the sides are not proportional. Therefore, the triangles are not similar. And I can't do anything with this one then. All right. We'll have examples on the back to work on this. The third method is side, side, side similarity. If all the sides of a triangle are proportional, I'm going to go ahead and abbreviate it to proportional. Proportional, make sure you write that in. To the corresponding sides of another triangle, then the triangles are similar. Okay, key word here, show that the sides are or are not proportional. I have a lot of people who will look at those and say, oh, side, side, side. No, you can't say that yet. You have to check and see that they're proportional. Well, AB is 2, matches up to the shortest side of that triangle. What's the shortest side on the other triangle? 3. So they've got to match up. So 2 matches up with 3. 4 is the largest side. On the other triangle, 6 is the largest side. So 4 matches up with 6. And then the last ones would be 3 and 4.5. Now, there are 2 ways of doing this. If you have a calculator, you could just type 2 divided by 3, you get 0.6 repeating. 4 divided by 6, and you would get 0.6 repeating. And if you did that with 3 and 4.5, you would also get 0.6 repeating, and you would be able to say the sides are proportional. Okay, that's just typing in the calculator. Let's say you don't have one or forget what to do. Here's what you could do. I think you can reduce 4/6. That reduces to 2/3. I think that's pretty easy. What you could do with 3 over 4.5 is actually multiply it by 10 to get rid of your decimal and then reduce it down as far as you can go. I can take 5 out of that. Actually, I can take 15 out of that. 30 divided by 15 is 2. 45 divided by 15 is 3. And it reduces down to your 2/3. Okay. So because all three of them reduce down to 2/3, the sides are all proportional, and you could say side, side, side similarity. Now, one thing I do want you to make sure you understood what I said there, because on a problem like this, I might say, what's the similarity ratio? And a lot of people are going to write 0.6 repeating. Don't do that. I need to see a fraction with a ratio. Okay, so you need to be able to change 3 over 4.5 into a fraction. So if you didn't catch that, watch that part over again. All right, or ask in class. Now, I've already said this. Say it again. You must prove triangles are similar before you can find a missing angle. Or set up a proportion to find the missing side. So what a lot of people do is they start trying to figure out the missing side. I want you to, like on number 1, I want you to find the missing side, ST. Okay, so I'm going to go in and I'm going to try and set up a proportion. 10 over 20 equals X over 15. Well, that's assuming that the triangles are similar. You can't assume that. If you assume that, you might be wrong. So I need to look at this and I need to say either angle, angle, side, or angle, or side, similarity. Well, it can't be side, because I'm missing a side on each triangle. I've got an angle congruent, T is congruent to X, but the corresponding sides here are X and 15. I actually can't. The only pair of sides that I know is 10 and 20. 8, I don't know the missing side. I don't know what that is. So 8 matches up with a question mark. I've only got one set of sides. I need at least 2. I've only got one angle. I need at least 2. Right? I need either 2 angles or 2 sides and an angle between them. I don't have either of those. There's not enough information here. So to find ST in this case is not possible. And that will be a situation that happens. There's not enough information to find the side ST here. All right, so next one. I've got an angle congruent to another angle. Do I have anything else here? Well, I've got 14 matching up with 24. I have X matching up with 22. Do I have any other angles? Hopefully you see that we do. Why are these congruent? Those would be vertical angles. So vertical angles theorem. So I have 2 angles congruent to 2 other angles. These are congruent, or sorry, similar by angle-angle similarity. I need to do that first. Because they're similar, I can now do a proportion. So 14 matches up with 24. Just like X matches up with 22. Now make sure X is on the smaller triangle. I put that on top in mine. Just make sure it matches up with the 14. And 22 goes on the bottom. Cross multiply. 24X. Sure, that's not writing. There we go. Equals whatever 14 times 22 is, 308. Divide by 24. You're not going to get a good number here. That's okay. You're going to get that sometimes here. You're going to get 77 over 6 if you leave it as a fraction. Or if you turn it to a decimal, it's like 12.83 repeating. The 3 is repeating. Okay. So yeah, Nasty numbers is a thing. You can actually have that happen here. Next one's tricky. Find the length of MP. Well, I've got two triangles, but one's sitting on top of the other one. So what I'm going to do is I'm going to redraw the small one. NMP. I know that's 8. I know that's 8. We're looking for MP. I'm going to draw the bigger one. That's NQR. Now, what's the side length of NQ? Take a second to think about that. NQ, a lot of people are going to put 10. No, that's MQ. NQ is 8 plus 10, which is 18. Same with NR. Do I have anything else on here that I know? I got 27 down here. It's not really going to help me because I don't know MP, so I can't say side, side, side. I would have to know every single side to say side, side, side. But I do have angle N in both triangles, right? So now I have to check, is 8 over 18 similar to 8 over 18? Well, yeah, they're the same fraction. So 8 over 18 and 8 over 18, and then the angle between them. Okay. By the way, that reduces to 4/9. I have side angle side similarity. Now I can use that 4/9 to help me find MP. So MP is on the smaller one, so on top here, and 27 is what it matches up with. So I get 9x equals 4 times 27, which is 108. Yeah. Divide by 9, and you get 12. All right. Last one for examples. If angle J is 29 and angle L is 34, find the measure of angle Q. Now, a lot of people are going to jump right in and they're going to say, oh, which one matches up with Q? Well, that's going to be the one that's between the long side and the short side. The long side is 60 and the short side is 32. So 29. Everybody's going to say 29 here. What did we forget to do? We did not check and see if the sides were proportional. So it's good that you're matching up short side with short side, 22 over 32. Long side with long side, so 40 over 60. And then the other side, so 30 matches up with 45. And then just start reducing. 30 and 45 reduces to 2/3. 40 and 60, can take 20 out of those, it reduces to 2/3. Looks good so far. 22 and 32, I can take 2 out of those, that's 11 out of 16. That is not 2/3. They don't match up, therefore sides are not proportional, which means it's not possible to find the measure of angle Q. You've got to check for that. That's what I'm trying to hammer into your head right here. Okay. Last thing for this lesson is indirect measurement. We use indirect measurement to find the heights or lengths of large or very large objects or immeasurable objects, like this picture here, a geyser. You can't take a tape measure up to a geyser and figure out how tall it is. Okay. There are two forms of indirect measurement. We've got a mirror method and we've got a shadow method. The mirror is here. The one below is actually the first. It's the mirror. This is the mirror. I put second. Wasn't supposed to put second. Supposed to put mirror. Okay. What's happening is you place a mirror on the ground and you back up. See the person here? The person's backing up until he sees the top of the geyser in the mirror. All right, so that's where he's standing. And then you can measure how tall he is. It's actually up to his eyes. So 6 feet from the ground to his eyes. How far from the mirror his feet are, just 7 feet. And then how far the geyser is from the mirror, which is 40.5 feet. The only thing we don't know is how tall the geyser is. Well, before I can figure anything out, I've got to understand that the triangles are similar. Well, the ground measured up is a right angle. You know, I can hardly see the red. Let's see if I can change colors here. Make it stand out. Okay. Those are right angles. So those are equal. And then you have to understand the part that's right here. The angle of incidence which is angle HVT. So hit the angle made by looking down at the mirror from his eyes, that's the angle of incidence, is always equal to the angle of reflection. In this case, that's angle JVS. So from the top of the geyser to the mirror down along the ground. Okay, so again, I'll get the white. This angle is congruent to this angle. So why are the triangles similar? Angle, angle, similarity. Because they're similar, I can set up a proportion. So 6 matches up with X, it's the height of each object. And then 7 matches up with 40.5. You could have done this a couple different ways, but that's one way. And then you can solve. 7x equals 243. Divide by 7, and you get x equals, or the geyser is 34.7 feet tall. Now, I talked about a shadow, right? So imagine we've got a person, right? My stick figure here, who's got a shadow, right? And then we've got this tree. It's really tall tree here. At the same time as casting a shadow. So you might know how tall you are, let's say 6 feet, and you cast a 5-foot shadow. You don't know how tall the tree is, but it casts a, I don't know, 30-foot shadow. You could figure out how tall the tree is by setting up a proportion. Okay, you got a right angle here. And the angle to the sun is equal to the angle to the sun, right? So it's angle similarity again. Okay. So you can set a proportion, 6 over x equals 5 over 30, and you can get your height. That's the shadow method. We'll talk about that more in class. And that is the end of this lesson.